Hello everyone, welcome to my talk. My name is Xiwei Xu. I'm a senior research scientist from CSIRO Data61, Australia. The title of my paper is a decision model for choosing patterns in blockchain-based applications. Other than myself, other authors include my colleagues Dylan, Tsinghua, Liming, Ingo Weber from Technical University of Berlin, and Lambas from CMU. The main research contribution of our paper is a set of decision models for guiding the selection of blockchain patterns. The decision models present each pattern's quality trade-offs and the relationship among patterns, which is currently fragmented in separate pattern collections. Such an overview of patterns across different publications can assist designers to navigate from one pattern to another until a suitable combination is found. The second research contribution is an expert opinion-based evaluation of the decision models against correctness, completeness, and usefulness of the model. Let's start from the context and the problem. Blockchain patterns have been captured by both academia and industry. The page on the right-hand side is an example of blockchain pattern, Oracle pattern, from our previous work, which includes summary, context, problem, forces, solution, consequences in terms of benefits and drawbacks, related patterns, and known uses. Selecting and applying patterns requires trade-off analysis. In practice, selecting patterns from pattern collection is non-trivial due to the limited information provided about relationships among patterns. Now let's move on to the decision models. Here are the three main stages to generate the decision models. The selection passes were identified mainly based on the related patterns section of each pattern. When we take a holistic view of multiple pattern collections, we were able to identify new selection passes based on our experience. The quality impacts and trade-offs were derived from the forces and consequences sections of the patterns. We then conducted an expert opinion-based evaluation. Based on the result, we refined the decision models with more precise explanation of quality trade-offs and the definition of the graphic notations. The figure on this slide gives an ideal design process for blockchain-based application. As with any software system, the process starts with the requirement elicitation. Then it is necessary to assess the suitability of applying blockchain technology against the requirements and the characteristics of the use case. In the case that blockchain is suitable, the next step is to decide what data to store on the blockchain or keep off-chain. Such distinction in terms of data management, performance, and security is needed because blockchain typically have limited computational and data storage capacity. Many use cases require a blockchain to interact with the real world. The component that connects blockchain with the external world is called an oracle. Smart contracts are programs running on blockchain. Many programming principles used in conventional software design are still applicable to smart contracts. For each of the boxes with bold label on this figure, we have built a decision model. Our notation borrows the gateways from BPMN. Every decision model has a high-level design goal represented by a gray box. The rectangles represent the patterns. A line with a double-headed arrow represents a complement relationship. Constraints of the pattern are presented by an octagon attached to the pattern. Impact on the non-functional properties are annotated on the arrows, we cover typical architecturally significant properties like performance, security, reliability, and modifiability. We also consider data qualities and unique blockchain properties like transparency and accountability. Due to time limitation, I will not go into details of the decision models. Please refer to our paper for more technical details. This slide shows the on-chain data management model. Just to give an example, the pattern in the middle is raw data on-chain, as we could read from the arrow pointing to that pattern. This pattern is applicable to scenarios with small-sized data, and the data size is also limited by the transaction size. Storing a piece of data on blockchain can improve integrity, transparency, but at the same time sacrifices performance, cost efficiency, and flexibility. To improve the confidentiality, the pattern encrypt on-chain data could be further applied. This is the off-chain part of data management. And performance model. Security is a cross-cutting concern that is applicable throughout the application. We derived the two decision models for authentication and authorization. An oracle can be characterized along three dimensions, including the direction of the data flow, the initiator of the data flow, and the decentralization of the deployment. Thus, the patterns covered by Oracle decision model include such dimensions of oracles. The last model is smart contract decision model, which is aimed to engineer multiple smart contracts. We then conduct a set of interviews to evaluate the correctness, completeness, and usefulness of the decision models. Here are the interview questions we asked. We asked our participants. We had 4 questions to evaluate the usefulness of individual decision model, and another 5 questions to evaluate the overall usefulness of decision model. We also asked general comments on how to improve the decision model. The participants affirmed that the decision models could provide design guidance during the design process. The workflow and the graphical illustrations bring structure into the design process. However, the current design models focus on application rather than the infrastructure, and are not friendly to people without any knowledge of the blockchain patterns. This slide lists some points we discussed in our validity and and limitation section. To address the subjective bias in expert feedback, the participants are selected from both industry and academia. All participants had 2 to 5 years of experience on multiple national-level blockchain projects. Regarding the reproducibility, we applied our knowledge to identify new relationships and selection paths among patterns when a comprehensive template is not used in the original literature. While this could affect the reproducibility, it is a necessary trade-off we had to make to bring structure into the decision model while pulling patterns from multiple collections. To conclude my talk, the research contribution of our paper is a set of decision models that assist developers in selecting patterns for blockchain-based applications. As future work, we plan to build an online decision model and collect feedback through our pattern website to improve the decision model iteratively. These are the references. Thank you for your attention.